Hi, this is Algebra 2, Lesson 38. We're going to talk about the powers of sums and solving by factoring, and only 0 equals 0. We're starting on page 172. Alright, we're going to start with the powers of sums. So we know that x squared equals x times x. We know that x to the fourth times y to the negative third times z squared, all raised to the second power, equals x to the eighth times y to the negative sixth times z to the fourth, because we used the power rule and multiplied this exponent by all of those. Okay? We know that 2x squared plus 3x, all raised to the second power, is the same as 2x squared plus 3y times 2x squared plus 3y. We can't just multiply the exponents, because it's a sum. So we actually have to multiply these times each other. We could do this two ways. We could use the FOIL method, or we can do it in the vertical method. We'll get the same answer either way. These are already written out horizontally, so I'm going to use FOIL. So the F stands for first, so 2x squared times 2x squared is 4x to the fourth. O stands for outers, so 2x squared times 3y is 6x squared y. Inners, that's 6x squared y. And then lasts, 9y squared. Okay, we have like terms here, so we can add them together, and we end up with 4x to the fourth plus 12x squared y plus 9y squared. Okay, so when we're expanding sums, we're not just going to raise things to powers, we actually have to expand, is the word we use for these. Okay, now, so let's try this one. We have x plus 3 cubed, quantity cubed. So that's going to be the same as x plus 3 times x plus 3 times x plus 3. The easiest way to do this is to take them two at a time. So we'll have x plus 3 times, and we're going to put these in brackets for right now, x plus 3 times x plus 3. Okay? We're just going to leave this guy outside the brackets and multiply these together, and then we'll multiply the product we get from these to this again. It's messy, but it works. So we have x plus 3, don't lose that. X times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. Okay? We can put like terms together. We get x plus 3, don't lose that out front, times x squared plus 6x plus 9. Okay? Now we've got x squared plus 6x plus 9 still multiplied times x plus 3. So we can distribute this. We multiply everything times x, and we multiply everything times 3. And then we put like terms together. Or we can do this vertically. And since we did this one horizontally, we'll do this one vertically just for fun. Come out with the same answer either way. So x squared plus 6x plus 9 times x plus 3. We get 27. And it's positive, plus 18x plus 3x squared. We have 9x plus 6x squared plus x cubed. And we add this together and we get x cubed plus 9x squared plus 27x plus 27. That is our answer. Okay? solving by factoring. If the product of two factors equals 0, then one of the factors must equal 0. If 4 times something equals 0, then we know that the something that goes in this parentheses has to be 0, because the only thing that 4 multiplies by to equal 0 is 0. So 4 times 0 equals 0. So if we have two parentheses, and we have something in this one and something in this one equals 0, then either this parenthesis or this parenthesis, or both, have to contain a 0. Which leads us to the zero factor theorem. If P and Q are any real numbers, and if P times Q equals 0, then either P equals 0, or Q equals 0, or they both equal 0. We use this theorem to solve equations by factoring. Remember, we can only do these with equations, not with expressions, so it has to have an equal sign. Okay, solve. We've got negative x plus x squared equals 6. We're going to start by moving all of the non-zero numbers to one side of the equation, and then we're going to rewrite it in descending power of the variables order. So we've got a 6 on this side. Let's move the 6 over here. We're going to rewrite this with the x squared first. So we'll have x squared minus x minus 6 equals 0. Okay, now we have a trinomial equals 0, and let's try to factor this trinomial. Trinomials factor into two binomials equals 0. This is x squared, so we'll have an x and an x. We've got negative 6, and we want to find factors of negative 6 that add to negative 1. And because this is negative, one of these is going to be positive and one of them is going to be negative. So the factors of negative 6 are negative 6 and 1, negative 1 and 6, negative 3 and 2, and negative 2 and 3. So we're going to want negative 3 and positive 2, because negative 3 plus positive 2 is negative 1. So now we have x plus 2 times x minus 3 equals 0. Because anytime you have something times something equals 0, one of these parentheses needs to equal 0, or they both equal 0. Okay? So in order for this equation to be true, either x plus 2 has to equal 0, or x minus 3 has to equal 0, or they both have to equal 0. If x plus 2 equals 0, then x equals negative 2. If x minus 3 equals 0, then x equals 3. So our answer is going to be x equals negative 2 or positive 3. And we just do the or with a comma. Okay? If we check this, if we put negative 2 and positive 3 back into the original problem, we'll have negative 2 plus negative 2 squared equals 6, and negative 3 plus 3 squared equals 6. These negatives cancel, so we have 2 plus negative 2 squared is 4 equals 6, and 2 plus 4 does equal 6, so that is true. So x could equal negative 2. Alright, so over here we have negative 3 plus 3 squared is 9 equals 6, and negative 3 plus 9 does equal 6, so this is also true. So x could equal 3. In either case, the answer will be 6. Okay? The zero factor theorem can be expanded. To the product of any number of factors. if A, B, C, D, etc., etc., etc. represent real numbers and A times B times C times D times E times F, etc., etc. equals 0, then one or more of the factors equal 0. What this means is we can do these with any number of factors. So we're going to start with this one. We've got negative 35x equals negative 2x squared minus x cubed. We're going to start by getting all of the non-zero numbers on one side. And just for the sake of prettiness later, I'm going to add these two to the other side instead of adding the 35x to this side. So it will be plus 2x squared plus x cubed to both sides. That leaves us with x cubed plus 2x squared minus 35x equals 0. If I had done it the other way, it would be negative x cubed minus 2x squared plus 35x. Either way, this will work. All right, so we have an x in each of these terms. So we're going to factor out an x, which will leave us an x in front and leave us with x squared plus 2x minus 35 equals 0. Okay? And now we can factor the binomial or the trinomial in the middle. So we have x, don't lose that x. It's going to be multiplied times 2 binomials equals 0, don't lose the equal 0. We've got x squared here, so we'll have x squared here. This is a negative, so we're going to have one positive and one negative. We need factors of negative 35 that add up to positive 2. And we've done this several times today, or recently. So that's going to be positive 7 and negative 5. All right, so now we have 3 factors that multiply together to equal 0. So that means that either x equals 0 or x plus 7 equals 0 or x minus 5 equals 0. Any of those could be true. X equals 0 we don't need to do anything with. That's already solved for x. Here we can subtract 7 from both sides and get x equals negative 7. Here we can add 5 to both sides and get x equals 5. So x equals 0, negative 7, or positive 5. That would be your answer. If we check this, checking is always a good idea for you to make sure you got your answer right. If we check this, we'll have negative 35. If x equals 0, then negative 35 times 0 equals negative 2 times 0 squared minus 0 cubed. All right, so we have 3 terms with 0, which means 0 equals 0, which is true. Okay? That was the easy one. Now we have negative 35 times negative 7 equals negative 2 times negative 7 squared minus negative 7 cubed. This is where your calculator comes in. So negative 35 times negative 7 is 245. It's positive because we have a negative times a negative, which equals negative 2 times negative 7 squared is positive 49 minus negative 7 cubed is negative 343. So 245 equals negative 2 times 49 is negative 98. Here are 2 negatives, so they cancel. And we've got positive 348. 245 equals 348 minus 98. And in fact, that is 245. So 245 equals 245, which is true. So x can equal negative 7. If this had turned out to be false, this negative 7 would have been incorrect and you need to go back and fix your mistake. So if this turns out to be false, don't leave it. Go back and fix your mistake. All right, one more check. We've got negative 35 times 5 equals negative 2 times 5 squared minus 5 cubed. Whew. Sorry, I shouldn't have squished them together like this. We've got negative 175 equals 5 squared is 25 times negative 2 is negative 50. 5 cubed is 125. Negative 175 does indeed equal negative 50 minus 125. So that is also true. All right. Only 0 can equal 0. If we solve the following two equations by factoring, the results are similar. So we have 3x cubed plus 2x squared minus 3x, 35x equals 0. We can start by factoring an x out. X squared plus 2x minus 35 equals 0. And then we factor these guys, and we actually just did this one. So I'm just going to copy it. We've got x and a minus and a plus. And this is going to be a positive 7 and a negative 5. And so we end up with x equals 0, and x equals 5, and x equals negative 7. I'm skipping ahead because we just did that. So x equals 0, 5, and negative 7. Okay, doesn't matter which order these guys go in, as long as make sure you get the pluses and minuses there. Okay, so we just came out with this answer. Let's try this one. Here we've got 2x squared minus 4x minus 70 equals 2. Our life is going to be easier here if we divide out a 2. Okay, so let's factor out a 2. And we'll have x squared minus 2x minus 35 equals 0. Oops, that's supposed to be a positive. That's better. So our inside here, inside the parentheses, stays exactly the same. We have 2 times x minus 5 times x plus 7 equals 0. Okay? When we pull this out, just like we did over here, we end up with 3 factors, and we've got 2 equals 0, and x minus 5 equals 0, and x plus 7 equals 0. So here x equals 5, here x equals negative 7, but then we've got this. 2 does not equal 0, only 0 equals 0. So if we end up with a constant on this side, 2 cannot equal 0. So we cannot put a 2 in here for these x's. That's not going to work. So x is only going to equal 5 and negative 7. Oops. I didn't need parentheses there. 5 equals, x equals 5 and negative 7. And 2 does not equal 0. Okay? That is it for this problem. Try your practice problems in your homework and let me know if you have any questions.